Hi everybody, it's Miss Dupree. In this lesson, we're going to take a look at earthquake damage and also learn how scientists can use technology to reduce the amount of damage caused by an earthquake. We know that earthquakes can cause incredible amounts of damage to buildings, to earth, that people die, but not all earthquakes are alike and not all places get the same damage. There are 4 factors that will determine how much damage an earthquake will cause in a specific place. The first factor is the magnitude of the earthquake. Remember, magnitude is the amount of energy released by an earthquake. So the higher the magnitude, like here's the high magnitude earthquake here, the more energy gets released and the more damage that earthquake is going to cause. The second factor is the distance from the epicenter. And remember, the epicenter is that spot on Earth's surface where the earthquake begins. The closer you are to the epicenter, like this location here, the more damage that you'll have. But the further that you are from the epicenter, the less damage. So these first 2 factors are really based on the earthquake itself, how strong it is and how far away it is. The next 2 factors are based on the conditions where you are. The third factor is the type of land that you're on. Softer land will result in more earthquake damage, while firmer land will result in less earthquake damage. In fact, really soft land can result in something called liquefaction that can happen during an earthquake. Liquefaction happens when really soft earth is shaken so hard that it actually acts like a liquid, and this can cause cars or even buildings to sink down into that earth during the earthquake. Okay, the last factor is the type of structure that you're in. The design of the house or building that you're in can make a huge difference in how much damage happens to that building. For example, shorter buildings are less likely to have damage, while taller buildings are more likely to have a damage from an earthquake. Materials like brick or stone, they're much more likely to break during an earthquake, while materials like wood and steel are less likely to break during an earthquake. So because the structure of buildings plays such a big role in earthquake damage, scientists have put a lot of research and effort into designing earthquake-resistant buildings. There are a few factors I want you to know about before you begin designing your earthquake-resistant structure. One of the more common design elements in earthquake-resistant buildings is called a truss. Now, most buildings and rooms inside buildings are made in square or rectangular shapes, right? Well, unfortunately, a square is actually a pretty weak shape. When earthquakes move from side to side, it's easy for that square to collapse at the corners, and that whole square is going to fall down. So builders can add trusses to the building, and a truss is just a diagonal support placed inside that square design, and it helps brace these corners, and it turns that square or rectangle into 2 or more triangles, and it just so happens that a triangle is the strongest shape that you can build. And now that you know what a truss is, you'll probably see them in lots of places. There are even trusses here at Lincoln School. The new soccer stadium has lots of trusses. Trusses are a really, really, really important aspect of building an earthquake-resistant structure. Another design element is flexibility. Buildings that are really stiff, really rigid, they're more likely to crack and break and collapse during an earthquake, because remember, the earthquake is moving the building from side to side. But if a building is more flexible, that means that it can bend and it can move with the earthquake. Excuse me. It can bend with those side to side movements, which means that it's less likely to break. So builders add materials to their buildings that can make them more flexible and more able to move with the earthquake instead of trying to stay straight and getting cracked. The last important design element I want you to know is having a strong base or bottom. As the earth is moving and shaking, a strong base down here at the bottom can absorb a lot of energy and can keep the rest of the building from moving around so much. So the stronger your base, the better your building will be able to withstand an earthquake. Okay, that's it for this lesson. Be sure that you know the 4 factors that determine how much damage an earthquake will cause, what a truss is, and how it helps make a building more earthquake resistant, and 2 more design elements to help make your building more earthquake resistant. If you have any questions, please ask. Otherwise, you're all set. Good job, everybody. See you next time.